Okay, so once again, this is a unit circle here with a radius of 1. And you're probably wondering, what is this wave about over here? And how does it apply to this circle? So what the wave is, and we're starting with sine, you can see that up here. What the wave is this tells you the height of the Ferris wheel, shall we say, depending on the angle. So again, this is where we would normally get on, right? See if I can move that up. No, it doesn't move. Okay, I thought maybe it did. So anyway, we start here, and this would be at 0. We get up to here, we're at 1. We come back here, we're at -1. And I mean, actually, we're at 0 as far as the height. Then we're at -1, and we come back to 0. And it just repeats that pattern as you go around the circle. So see how it's going there? So when you get to the top of the Ferris wheel, you get to the top of the graph, right there. So it's sort of like converting a Ferris wheel into a roller coaster. Okay. So again, so when we're at 0, we're at 0. When we're at 180, we're at 0 again. And then back to 0. There's 180. So you can see here they're doing by degrees, and then they could also do this by radians. So every 360 degrees here would be 2 pi for radians. Okay, there's probably some place to change that, but I don't know where it is offhand. Okay. So if I pause, see I'm almost up at the top here. So it's almost at 1. So the sine wave bounces back and forth between +1, which is this guy, and -1, which is this guy. And it just kind of goes in between. And then when we hit 0, we're at 0. And when we hit 180, so here's 0, we're at 0, right? And at 180, we're back to 0. And at 360, that's going all the way around, we come back to 0 again. Okay? Does that make sense? So here we're just talking about the height. So that's sine. And sine goes with y. So we're talking about how high up you are or how far down you are. Okay? So the part that we're looking at on the graph is the dotted line that you see right here going by. So the height of that dotted line is the same as the height of this sine wave. And this is what's known as a periodic function because it repeats every 360 degrees, right? Because every time we start here at 0, we go up here, we're here at 90, we're back here at 180, we're down here at 270, and we come back to 360, and then the pattern repeats. Okay? So let's talk about cosine. So cosine is how far are we left and right. So again, it'll bounce back and forth between 1 and -1, but we'll start here at 1 because that's where you get on the Ferris wheel. You're getting on the Ferris wheel, in this case, the furthest to the right. And then as you go up, you'll eventually get as far as you can go left, and then you'll come back over to the right. So let's switch over to cosine. So you see it looks pretty much the same because it's bouncing back and forth from the same spot. But this time, what we're looking at is the little dotted line in red. It's like, how far am I to the left or how far am I to the right? Okay. So if it's a little confusing, let's get rid of the sine wave for right now. Well, I was trying to get rid of it, but it didn't go away. Interesting. All right, so that's what we got going on there. Still the sine wave again. Let's go to cosine and see if we can get started over. Yeah, it keeps going back to sine. Let's do this fast. So there you can see the two go on at the same time. All right, so I just thought this animation was pretty good for this kind of stuff. All right, so the tangent is something completely different. Because remember, the tangent is the sine over the cosine. So check out what this stuff does. So this guy. All right. I'm just going to go back to the sine of it. So let's look at the tangent. Let's see what kind of weird things it does. So I'm going to catch it when we get to 0. So look at the weird things that are going on here with tangent. Tangent, we get a bunch of wavy lines. Okay. The reason we get the wavy lines is, remember, tangent is sine over cosine. So anytime that the sine, or excuse me, anytime the cosine is 0, then our wave is undefined. And the reason for that is if you have sine over cosine, if cosine is 0, then you have some number, usually 1 or negative 1, over 0, which is undefined. So that's why you get these waves like that. Now, we won't talk as much about tangent as we will sine and cosine, but just to kind of give you guys an idea about it. All right. So we're going to talk about some of the different aspects of this. I don't know if we can change parameters in this guy or not. Yeah, this is just the unit circle itself. So. All right, so that gives you some idea where these graphs come from. All right, I'm going to go ahead and switch over to our regular stuff. So this will go away for a second, and then I'll be back with the other screen. Okay. So can we see now? Can we see the kid on the unicycle? All right. So this is some stuff out of your book. This is section 7.4. So it says define the domain, range, and period of the function y equals cosine of x. So again, here's what we're saying. Here is where we start at 0, and at 0 we are all the way to the right on the unit circle. So that means that y is going to be 0, and x is going to be 1. So again, this is saying we're going to start at 1, we come down, we'll come back up. All right, so domain, that's possible x values. Now, what I've told you about domain still applies even with the trig function. When you look at the trig function here, we've got y equals cosine x, right? You ask yourself two questions, same two questions we always ask. First question is, do we have an x under a square root? Do we have an x under a square root? Nope. Good. Do we have an x in the bottom of a fraction? So do we have an x as a denominator in a fraction? No. If you can say no to both those questions, your domain is all real numbers. So any number, any x value here is going to work. Now this one's using the pi's, this is using the radians, but you could use the degrees as well. So again, this would be 0 degrees, this would be 90 degrees. Remember, pi is 180. is 180 degrees, 270, and 360, or 2 pi. Okay? So degrees or radians works either way. We prefer degrees, I know. Okay, so that's your domain. So range is possible y values. All right. So on this graph, what's the highest value for y? What's the highest we go up? Yeah. And what's the lowest we go? -1. Okay, so that means your range bounces back and forth between 1 and -1. So if we were writing that stuff down, which needs something to draw with here, so we would say that our domain is all real numbers, and that's too thick. Fix that a little bit. So all real hashtags. And then our range, we just figured out, is y bounces back and forth between -1 and 1. Okay? So we never get higher than 1, we never get lower than -1. Okay, so let's talk about the period. The period is how much do we go along the x-axis until this thing repeats. Let's use a different color because that orange looks like the orange they're using. So we start here, and come down, and come back up, and it looks like the pattern starts repeating here. So we start at 0. Where did we end up at? Okay, we don't like pi's. If this was degrees, what's one trip around the circle? Yeah, 360. And 360 is also 2 pi. Because 1 pi is 180, so 2 pi is 360. So the standard period of a cosine function, so the period here is just going to be 2 pi. Okay? And that's going to come in handy later. All right, so there's some different things that we can change on these. And I'm just going to bring another slide in here. Okay, so we start off with the basic thing, right? We got cosine of x. All right. So here's how we do this. If we put a number out front, say 2, then we multiply everything on the function by 2. So our function is going to be twice as tall. So a roller coaster is going to be twice as tall. So in our original one back here, we bounce back and forth between -1 and 1. If we double it up, what numbers are we going to bounce back and forth between now? So the original one was 1 and -1. What are we going to bounce back and forth between now if we double up the function? Yeah, exactly. So the lowest it'll go will be 2, and the highest it'll go be +2. So this number out front, they give this a special name. Okay? And what we call that an amplitude. An amplitude is just telling you how big the roller coaster is. Well, like you said, this part here would go between a low of -1 and a high of 1. So if you had -1, then you doubled it up, you get the -2. If you had plus 1 and you doubled it up, you get the plus 2. See how that works? So maybe, yeah, let's maybe bring in Desmos. We'll pull out the heavy artillery today. We had the animation earlier, and then we'll do some Desmos here. All right, so Desmos incoming. All right, so let's go down here. And we'll go to functions, we'll go to trig functions, we'll go to cosine. So cosine of x. All right, so there's our guy. So he's bouncing back and forth between 1 and minus 1, right? So if we stick a 2 out front, roller coaster gets taller, right? So now it's bouncing back and forth between 2 and negative 2. Okay? And the bigger you make the number up front, the bigger your roller coaster gets. So this one's going to bounce back and forth between 4 and negative 4. Now, the period didn't change, because to go from here to here is 2 pi. That's 1 trip around the circle. Okay? So again, this number out front, we call this the amplitude. All right? So the amplitude is pretty much telling you that this is our low point and this is our high point. And how much do we go above or below the center line here? So obviously we go up 4 or down 4. So it's just the distance from the center line to either the top or the bottom. And they're just using the absolute value or the positive value because they're talking about a distance away from the center line. So distance is always positive. So it's going to be 4 and a 4. So even if they would have like a minus 4 cosine x, you would still say the amplitude's 4. Okay, so amplitude's always positive. Okay, so that's one thing that happens. All right, so let's drop him back down a little bit. So we'll give it 2 so we can see it a little better. All right, so that's one thing we can do. Another thing we can do is, just like we've done in the past, we can move it up and down just by putting a number on the outside. Now, the number is not part of the cosine, okay? So let's just do another one here just so we can compare. All right, so let's get out our cosine function again. Over here, cosine x. All right, so we'll make it 2x, so they match up. Okay, so now the red one and the blue one are the same, right? So another thing we can do, and we can do this with any function, is we can move it up and down, and we just do that by adding the number onto the end. So notice there, the function in blue is now 1 higher than the function in red. So here's the function in red. He tops out at 2, right? Where the function in blue tops out at 3. So we move the whole thing up 1, which also means the original guy bottoms out. Let's get this guy out of the way. The original guy bottoms out here at -2, where the new guy in blue is going to bottom out at -1, because you'd have -1, you'd have -2, and then +1 is -2. So it just moves you up and down. And then same thing here, if you decide you want to move it down, so we'll say -2. So it just moves the whole thing up and down. Notice the wave stays the same. This looks like roads in West Virginia if you've ever been to West Virginia. I swear there's times that you can see the back end of your own car when you're going around some of these curves. Okay. So we can move up and down. Now, notice so far, we haven't like made this period any different. The period's always been 2 pi, right? So we start here at 0, and we start repeating our pattern at 2 pi, and that happens every 2 pi. So here we're negative 2 pi, add 2 pi, you get 0, add 2 pi, you get 2 pi, you get the idea. Okay, so what happens if I put a number in front of the x rather than in front of the whole function? So let's try that. Oh, what's going on there? That's a pretty cool looking pattern. All right, so let's get this guy out of here so we don't confuse ourselves. All right, so notice what happened there. We're bebopping along here. We got a nice flowing wave, and then I put a number in front of it, and now look what's going on. This thing's going twice as fast. So notice here, if we do one cycle, we're at pi instead of pi over 2. Or no, excuse me, instead of 2 pi, excuse me. So what happens here, by the time you get to 2 pi, we have gone 2 full cycles. So what we've got now is a 2-for-1 special. Now if we go back to the other one, so notice here, we're still at 2 pi, but we only have 1 complete cycle, so we're getting ready to repeat again. But when we put the 2 in there, this thing does a cycle, does another cycle when it gets to 2 pi. So the period has changed. The original period is 2 pi. This is the point where it's going to start repeating, right? But then I put a 2 in here, the pattern starts repeating at pi. Now think of it in this way. So say you're taking a trip and it's 60 miles away, right? You hop on the expressway, you set your cruise control to 60 miles an hour, you get there in an hour, right? Okay, so suppose that you're out in the desert someplace and there's not a lot of cars around, and you've got a really fast car. And your fast car can do 120 miles an hour. Okay. That means you can travel 60 miles in half an hour. Okay. So the point of the story is if there's a number in front of the x, it means you get there twice as fast, right? So this means we go twice as fast, which means the time it takes us is only half as long. So instead of the period or the time to get there being 2 pi, the time is now pi. Okay? So the basic formula for this is whatever number is in front of the x, you take 2 pi and divide it by that number, and you will get your new period. So let's pop back to the other thing real quick. So what we're saying is if you stick a number out front here, right? So if I put a 2 there, so the standard function, standard period for a cosine and a sine function. So your standard period is 2 pi. 2 pi is the same as 360. One trip around the circle. Okay. But if you double it up like this, what you do is you take your standard period, which is 2 pi, and divide it by 2. So 2 pi divided by 2 is just pi. So twice the speed, half the time. So regular speed, it takes 2 pi to get there. Double the speed, it takes pi to get there. And by the same token, if you're going half as fast, you'd write that like this. You'd say 2 pi divided by 1/2. And that would give you 4 pi. So if you're going half the speed, it takes you twice as long to get there. So again, if we're doing like our 60-mile trip and we're on the expressway, we're doing 60 miles an hour, well, we decide to take the scenic route down 19, okay? Then it takes twice as long. We can only go about 30 miles an hour. So it takes twice as long to get there, okay? So all you have to remember with this is 2 pi is our standard. If there's any number in front of the x, whether it's a fraction, a decimal, or a regular number, we just take the standard period and divide it by the number in front of the x. And that will give you the period for that particular function. And that's what we saw once again when we were looking at the decimals. Get the decimals to come back up. That would be cool. There we go. So again, by putting that 2 in front, it goes twice as fast as when we don't have the 2. So think of it kind of like a time. The time is twice as fast. And the bigger number you put in front, the more you start getting the wave. Pretty soon, this thing starts looking like a slinky. Okay? And then again, if you put like 0.5 in front, see how different that is? So this time, in order to do one cycle, we had to go all the way to 4 pi. Going half as fast takes twice as long. Make sense? Okay. So yeah, trigonometry is interesting because it pulls together a lot of different things you use in both geometry and algebra all into one spot. And again, it actually happens to be pretty useful too, because this kind of thing, this is how they model, like, say, sound waves, things like that. Oftentimes they will talk about like the frequency of a sound wave. The frequency is how many times does your pattern repeat. That's exactly what this is. Okay. So like the human voice for most people is around what they call 1,000 hertz or one kilohertz. Okay. So 1,000 hertz means that the pattern or the wave of your voice repeats about 1,000 times every second. That's kind of weird to think about, right? And the higher the frequency of your voice, the higher the pitch of the sound. So my voice is probably around 1,000, like I said, probably about the standard. You know, somebody with like a several octave range, like a Mariah Carey or somebody like that, would be maybe closer to like 1,200, 1,500, something like that, because they can make their vocal cords go faster and therefore higher. So that's what's going on when you're singing, is you're changing the frequency of your voice. And then if you're into music, like the bass end of things, like the low end, is low frequency. So a bass guitar has a lower frequency than, say, a lead guitar, or a really shrill instrument like a piccolo or something like that has a higher frequency than, like, say, like a bass or a cello or something like that, to put it into musical terms. Okay. So, like I say, once again, a lot of this trigonometry stuff is a lot more functional than most math stuff we talk about. All right, so let's go back to our regularly scheduled program. All right, so this says, what are the amplitude and the period of each function? So this is what we were just talking about. So amplitude's easy. Amplitude is the number in front of either the sine or the cosine function. So what's the amplitude on our first guy? What's the amplitude for number 14? Yeah, just 1/2. So that's your amplitude right there. And how about 15? What's the amplitude there? Yeah. So when they ask you amplitude, that's one of the easiest things they can ask you. It's just the number in front of the sine of the cosine function. Okay? So now, the period is a little bit harder, but not much. Okay? So again, think of it this way. The standard period for cosine or sine is 2 pi. That is the standard time it takes to get around the circle one time, right? So this guy is only going 1/8 as fast. So he's probably not in the car, he's probably riding his bike or something, or a skateboard, or something like that. So he's only going 1/8 as fast, so it's going to take 8 times longer to get there. So instead of being 2 pi, it takes 8 times longer, it's going to be 2 times 8, that's going to be 16 pi. So that one's going to be real stretched out. That function is going to go real slow up and down. Okay? And again, the way you get this is you say 2 pi and then divided by 1/8. Okay? Now remember, 2 pi divided by 1/8 is the same as saying 2 pi times 8 over 1. Because what do you do when you divide by a fraction? You flip and multiply. And as we said, 2 times 8 is going to be 16. Okay? So that's for that guy. Then we do the same thing over here. So this one again, we start off with a standard of 2 pi. We're only going 1/4 as fast, right? So it's going to take us 4 times longer to get there. So how many pi is our period here? Yeah, that's all it is. So remember, dividing by 1/4 is the same as multiplying by 4. Dividing by 1/8 is the same as multiplying by 8. Okay? So this guy, again, while he's going to be kind of spread out, he's not as spread out as this guy. Okay, does that make sense? So again, the number in front of your sine or cosine is the amplitude. That tells you how tall your roller coaster is. So we got 1/2 here. This is the kiddie coaster, right? It's only half as tall as it normally is. And over here, this is the wicked roller coaster. It's 5 times bigger than the average coaster. Okay? And then these guys in front of the x tells you your period. And you just take 2 pi, divide by whatever this number is, and that gives you your period. Okay? And then same thing over here. You took 2 pi, we divided by 1/4, and ended up getting 8 pi. Questions? All right, well, that's probably a good place to stop for today. Again, we've been throwing a lot of information at you, give you guys a little chance to process it, and we'll convene next time. All right, well, I appreciate you stopping by, and we'll pick it up all again tomorrow.